This is the EXSC120 Assessment 2 Mechanical Changes presentation exploring the launch velocity of the ball during a football kick. The video was filmed outdoors with the sun directly behind the camera. This enables the sun to be directly parallel to the movement, thus reducing parallax error. Due to the use of a phone camera with limited shutter speed settings, I couldn't determine or change the shutter speed of my camera whilst recording. This may prove as a limitation in a video analysis, as being able to opt for a higher shutter speed allows for less time between video frames, resulting in a higher quality analysis. The tracker motion software has been utilised as a means of measuring the initial velocity of the ball. The video was taken in line with the action in the sagittal plane. The camera was placed 10 metres from the subject and the picture was zoomed in to enlarge both the subject and the ball for a better quality analysis. Both of these methods aid in the prevention of perspective error. 2 bottle caps were used to mark a 4 metre distance on the grass. The distance has been calibrated into the tracker software as shown by the blue line at the bottom of the image. In the field of view, we have the participant, no shadows, and no other objects obstructing the picture. Following his first attempt at the football kick, the participant was instructed to lean back in his next attempt. The intention of this feedback was for the participant to adopt a greater backwards trunk lean upon impact with the football. So here we have 2 images of the subject's initial impact with the ball, which have been taken from the video recordings. The flight path of the ball from being dropped to post-impact flight is represented by the orange line in both images. On the left, we see the technique of the subject before the intervention strategy was instructed, and as we can see, the subject has a rather straight, if not somewhat flexed trunk upon impact with the ball, while on the right, following the intervention instructions of leaning back, we see a much greater backwards lean of the participant's trunk upon impact with the ball. A quick note about the image on the right, the tracker software didn't provide the exact frame at which the participant struck the ball, so the first frame in which foot contact with the ball is observed has been used. This graph represents the velocity of the football before and after the increased backwards trunk lean upon impact. So as we can see here, the launch velocity of the football pre-intervention was 8.20 metres per second, and again the intervention involved asking the participant to increase their backwards trunk lean following their first attempt at the football kick. Following these instructions, the participants saw a launch velocity of 12.72 metres per second in their second attempt at the football kick. By generating a greater backwards trunk lean upon impact, the subject was able to increase the launch velocity of the ball by 4.52 metres per second. The launch velocity and the release angle of the football were used to calculate its horizontal displacement both pre- and post-intervention. Pre-intervention, the horizontal displacement of the ball was calculated to be 6.76 metres, while following the intervention, the ball's horizontal displacement was calculated to be 16.45 metres. So ultimately, the intervention caused an increase of the ball's horizontal displacement by 9.69 metres. By generating a greater backwards trunk lean upon impact with the football, the acceleration path of the leg is maximised, allowing the leg to travel over a greater distance and therefore generate more velocity. The increased velocity of the foot upon impact with the ball ultimately increases the launch velocity of the ball. The stretch shortening cycle of the hip flexor muscles also increases. The hip flexor muscles are able to elongate more due to the increased backwards trunk lean, causing a greater amount of contraction in these muscles prior to foot impact on the ball. This increased contractile capability of the hip flexor muscles allows for more force to be generated in the leg kick, which is then translated onto the football upon impact, causing a higher launch velocity. And finally, the angle of trajectory of the ball lowered from 49.9 degrees pre-intervention to 44.7 degrees post-intervention. As the relative projection height of the ball is near zero, a 45-degree trajectory launch angle is optimal for maximum horizontal displacement. This concept correlates with the post-intervention kick, as the angle of trajectory of the ball was 44.7 degrees, and this effort saw a greater horizontal displacement of the ball.